Hi, welcome back to the old shop. It seems like it took forever to get this one done, but I got all the little segments put together and I think I got something that you might enjoy. We have a couple of little repair jobs to do and one other one for the shop that I'll explain as some shaper work. And I got some viewer mail. Brian Block sent this to me. He was a little concerned that after we got the governor straightened out, we really didn't know how fast we were going. Because the end of I can't put my tachometer on the end of this shaft, and the other shaft is too close to the wall to read it. So he sent me an extra electronic tack that he had. There it is right there. And a little note that says, "Hi Dave, enjoyed your videos and think that old steam powered shop is awesome. Keep the history alive, Brian Block." Well, thanks Brian, I appreciate it. And we're gonna see what we got right now. I taped a little piece of tin foil to the flywheel. There. 217 RPM, give or take one. You can see it's not quite steady. So that's fine. You might want to go a little bit faster, but for the time being, I think we're going to leave it where it's at. Well, this monstrosity here sitting in the middle of my shop doesn't really belong in here, in that it's newer than most of this stuff. It's a horizontal boring mill, and it was pretty beat up when I got it, abused, and sat outside for a while. Took me about a year to get things broke loose and working on it. But boy, does it come in handy for some of the bigger jobs. It is featured in a little job that I did a week or so ago on a motorcycle cylinder head, and I'll show you that in a minute. Got a big old chuck with it. That's 16-inch wide. Weighs 8,500 pounds. That boring head will go up the mast quite a ways, and you have a tailstock which also moves with a lead screw, and it's synchronized with the boring head, so you can put a real big bar through here and turn some really big fly cutters. You can use it as a milling machine. You can set things up with an angle plate. Very handy machine. So I got a little job on a motorcycle cylinder head, and I'll show you that in a minute. I had this job in the shop, and it's not really involved in the old time machine end of my shop, but I got it about half done, and then I thought, well, maybe you might like to see it. So I'll just quickly show you what's going on here. This is a head from a 750 Norton motorcycle, a customer of mine that works on British bikes, and in an attempt to helicoil one of these three studs here, this one over here, went crooked on him and sort of messed it up. So he asked me if I would figure out a way to fix it. So what I did was I set it up in my small boring mill. It's a horizontal boring mill on an angle plate, And so I got the hole drilled out exactly perpendicular to the gasket surface, and I tapped it 1/2 inch fine American thread, and I'm going to screw a 1/2 inch fine bolt in there and machine it off flat, and then locate the center of it using the head gasket for a template, and then drill the 3/8 hole and tap it for the 3/8 stud. So it's sort of like an insert that fixes the threads. It's a British standard thread, a standard. And I happen to have a tap. Actually, it belonged to the customer, so we got everything we need to do this job, and so I will pick it up when I get the insert installed and ready to put it back in the boring mill to bore the hole. Well, I looked in my machinist manual, and for British standard fine thread, they're showing a minor diameter of 311. No tap drill size, so I'm going to try a 5/16, which is 312.5, and we'll see what we can do with that, tapping it. Finish it up by hand. Okay, I don't know if you can see the finished hole or not. It's this one right here. And screw the stud in. And that should fix Mike right up. This is something that I just set up on the boiler the other day, and I haven't even had a chance to test it out yet. But it's a handy dandy little thing called an ejector. On the last video I showed you what an injector does. It puts water into the boiler. This little device will put water somewhere else using steam power. It's a real simple thing. The steam comes in here and through an orifice across the chamber into another orifice, and it sucks the water in behind it. Sort of like one of them little Venturi pumps you use with a garden hose to bail your boat out with. And supposedly it uses very little steam. And I got it set up here with a pipe out to my rainwater barrel so I can fill my inside feed water barrels, either one of them, with this ejector. So I'm going to start it up and we'll see if it works. I'll open one of these up. And it's piped up to the steam over here. I had to tear all this piping out so I could put this valve in. And there she goes. Look at that. It doesn't have to lift it very far. The barrel's only about maybe 3 feet lower than this, but it sure is handy. A little air in the pipe. Alright, turn the steam down just a little bit and it can straighten it right out. Open this one up. I have 2 machines in the shop which I would like to recognize as World War II veterans. There's certified veterans of World War II. This is the 9-inch South Bend Junior lathe, and if you look at this tag, it says New York State Educational Department, National Defense Training. And also, the Brown & Sharp milling machine, oldest machine I've got. Also certified. These 2 machines were sold at auction after World War II. They came out of the local high school here at a time when they were training young people to be machinists and work in the war effort. And after the war was over, why, they were just old, junky old machines and they couldn't wait to get rid of them. So they ended up here in 1949. My father bought them, and that was the beginning of his little personal machine shop. Thought you'd like to see that. In order to get the stroke right on this, you got to run the shaper back, the ram back as far as it will go. Okay. And we want about 3/4 of an inch over on the end, so about 13.5. And here's the little scale here. So run that to, there's 13, it's between 12 and 14, so it'll go a little more, that's about 13.5. lock that down. And then this will position a ram on the work. We'll leave about a ½ an inch. And that should do it right there. Now what this is a couple of 1.5 inch pieces that I unceremoniously sawed out, and they're bolted together with countersunk screws in the back. So all I want to do is square this block up, and then I'm gonna, on the horizontal mill, I'm gonna cut a 7/16 groove on both sides for key. For one side will be the key for the dividing head, which will sit on this surface, and the other side will be the key to go in the T-slot of the milling machine. So what I want to do is just cut this mess down flat. About 80 thousandths pass, and the feed is about 20 thousandths per stroke. Making our belt slip a little bit. the deal with the spacer. This is the dividing head. It has a Caterpillar 50 adapter. And I'll eventually mount a chuck on here. And a friend of mine gave me this, and I sort of rebuilt it. I like it. It's pretty high. I was going to try to cut it down, but then I thought, well, it'd be nice to be able to swing a large diameter here for like a big gear or something if you were cutting teeth in a big gear. So I've got about 3 1/8 inches. So I got to build this up, and then I'll fine tune it by in the shaper, cutting some off the bottom of this. This flat here, if I take the wheel off, will be parallel to this, so it'll give me something good to bolt it down to. It's got a keyway here, and it's the same in the on the bottom of this. So those keys will match the T-slots in the milling machine. Now we got her cleaning up all the way across. One finish cut after this, and we'll have it. There you got the rough cut. You can see the cuts. They're about 30 thousandths apart. Got it cleaned up all the way across. So we'll give it another maybe 5 thousandths with a slower feed, and that'll be our finished cut. Ten thousandths feed, 10 thousandths cut. Okay, there you have the final pass. I don't know if you can see it very good. When the sun goes down, the light gets bad in here, and it's kind of hard to shoot video. But I don't know if you can see. There's lines going this way, little patterns. You can't, this feels very, very smooth, and you can't really feel them, but you can see them. And it can't be vibration or chatter from the tool because it's the same on every pass. I believe it's the pattern of the bowl gear on the main gear that drives the ram. It's not a perfect power impulse as it drives the ram, and if you put your hand up here on this one, it's moving, you can just feel it. But because it's exactly the same every time, it leaves a little, the power impulses are just a little bit microscopically jerky, and that's what you're seeing in there. Typical fine finish for a shaper.